All right, so problem 29. A bag contains red balls and white balls. If 5 balls are to be pulled from the bag with replacement, this is important, the probability of getting exactly 3 red balls is 32 times the probability of getting exactly 1 red ball. What percent of the balls originally in the bag are red? And this should be pretty familiar. It's basically the exact same problem as 27. It's for all intents and purposes, it's the same problem, just with different numbers. Okay, and this one's also more complicated. So the probability of getting exactly 3 red balls. What is that? How do we calculate the probability of getting exactly 3 red balls? So what that means is we get 1 red, 1 red, 1 red, and 2 whites. And so what's the probability that this happens? Well, there's 10 different orders in which we can get this in. There's 5 choose 2, which equals 5 times 4 over 2, which equals 10. There's 10 different ways to place 2 whites onto to like order the whites in the 5 balls. And so yeah, that means that, for example, R, W, W, or like W, R, W, R, R. There's 10 different arrangements like this. And there's 10 different orders in which we can eventually get up to 3 reds and 2 whites. So that means that the probability of getting exactly 3 red balls is 5 choose 3 to choose the order in which we'll get those red balls times R cubed times W squared, where R is the probability of getting a red ball and W is the probability of getting a white ball. And then this is equal to 32 times the probability of getting exactly 1 red ball. So 1 red ball would be 1 red and 4 whites. And so there's 5 ways to order this time. For example, we could have red, white, 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 red, white, white, white. So there's 5 different ways to get to 1 red and 4 whites by pulling out 5 balls. So then this equals 5 choose 1 times R times omega times W to the 4th. And then now you're just solving the equation. So this thing on the left is 5. This thing over here is 10. And then you cancel 10 from both sides. And so R squared equals 16W squared. So R equals 4W. And so that means that the probability of getting a red is 4 times the probability of getting a white. And since the total probability, since the red and white should sum to 100%, R plus W equals 5W equals 1. So W equals 20% and red equals 80%. In general, if you're pulling out, let's say, N balls, and you want to have like X reds and Y whites, the colors are not important, then the probability of this happening is N choose X times the probability of getting a red to the X times the probability of getting a white to the Y.